Hi there, my name is Katherine Power, and today I will be presenting on my honors research project, Regional Structural Controls on Hydrothermal Fluid Flow in the North Fiji Basin. The North Fiji Basin is the largest area of active back arc spreading in the Southwest Pacific, continuously opening since the Miocene. Previous studies have suggested a complicated history of microplate interactions, rotation, and reorganization, with crestal scale structures having a strong influence on magnetic and hydrothermal activity. The North Fiji Basin is located within a buffer zone between the Pacific and Australian plates, with the Australian plate subducting beneath the North Fiji Basin along the New Hebrides Trench. The North Fiji Basin is bound by the inactive Vietas Trench to the north, the Fiji Platform to the east, the Matthew Hunter Fracture Zone to the south, and the New Hebrides Island Arc to the west. BIRD identified 3 microplates, the Balmoral Reef, Conway Reef, and New Hebrides microplate within the North Fiji Basin, and classified the region as an origin to recognize that the area is tectonically complicated and the microplates and their boundaries are difficult to define. The microplates are divided along active plate boundary segments such as the Fiji Fracture Zone, the Viwa Rift, the Hazelholme Ridge, the South Pandora Ridge, the Central Spreading Ridge, the Monzier Rift, the Essen Spreading Center, and the New Hebrides and Matthew Hunter subduction zones. The objective of this study is to better understand the link between crestal scale features, hydrothermal pathways, and the evolution of the North Fiji Basin. To identify crestal scale features, 2 datasets were used: satellite-derived vertical gravity gradient and a global compilation of magnetic data. These were both used within a geographic information system project to shed light on deeper crestal structures. VGG enhances short wavelength variations in the gravity field, which highlights fine scale structures in oceanic crust. Magnetic anomalies are local variations in the Earth's magnetic field caused by the chemical or magnetic properties of the rocks and are used to identify the age and spreading history of oceanic crust. Crestal scale features were mapped as lineaments at 1 to 500,000 scale. Over 1,385 lineaments were digitized from the VGG dataset and 224 for the magnetic anomaly dataset. The average length for the VGG lineaments is 20 kilometers and 60 kilometers for the magnetic anomalies. Regions with similarly oriented lineaments were grouped into tectonic domains to construct the history of the North Fiji Basin. Based on the density of the lineaments constructed and the amount of domains identified, VGG records the history of the basin in more detail. By analyzing the VGG data, we were able to interpret 35 domains in the crust, including rifts, trenches, troughs, ridges, faults, corresponding back arc basin crusts that have common tectonic history. In areas where there is spreading, such as around the Central Spreading Ridge, the tectonic fabric parallel on both sides of the spreading ridge show that this crust formed from the same spreading center. The South Pandora and Hazelholme Ridge that have areas of slow spreading show much higher values in the VGG signal, whereas moderate spreading crusts are delineated by lower VGG signals. Similarly, cross-cutting features suggest different tectonic origins. By further grouping these areas together, we can have a better understanding of how the basin developed. The majority of the large-scale structures are formed during accretion at spreading centers. However, in several areas, cross-cutting structures can be observed that indicate a more complex evolution of these areas, particularly adjacent to plate boundaries. The structures in present-day microplate mosaics provide a useful framework for understanding how and where crestal scale faults and hydrothermal pathways form in analogous terrains on land. In conclusion, by interrogating VGG and magnetic anomaly data, I was able to create a lineament domain map of the North Fiji Basin. By identifying 35 domains, we were able to find areas of the same orientation and tectonic setting, identifying multiple stages of crustal growth and evolution in back arc basins. Characterizing crestal scale structures in modern analogs may help to better understand how and where crestal scale faults form and subsequently deform. Thank you.